Hello there, welcome to the show. I hope you are doing well. In the previous episode of the series, we discussed acid in our daily life. Today we are going to discuss the chemistry of bases. So, let's begin the show. A base in chemistry is a substance that can accept protons or donate pairs of electrons. Bases are often characterized by their ability to neutralize acid, producing salt and water in a chemical reaction called neutralization. Bases are the opposite of acids and are essential components of pH scale, which measures the acidity or basicity of a solution. They can also change the color of certain indicators, such as turning red litmus paper blue. Bases are formed through various processes, and their formation depends on the specific compounds and reaction involved. Here are few common ways in which base can be formed: dissociation of ionic compounds, reaction of metal oxides with water, and neutralization reaction. Bases possess several characteristic properties that distinguish them from other substances. Here are some common properties of bases. Bitter taste. Many bases have a bitter taste, although this property is not always a reliable indicator. Slippery or soapy texture. Bases, when dissolved in water, often exhibit a slippery or soapy feel. Conductivity. Bases are generally good conductors of electricity when dissolved in water or in molten state. pH value greater than 7. Bases have a pH value higher than 7 on the pH scale. Reaction with acids. Bases and acids react with each other in a chemical process called neutralization. Color change with indicators. Bases can cause certain indicators, such as litmus paper, to change color. They turn red litmus paper blue and do not affect blue litmus paper. These properties help us identify, classify, and understand the behavior of bases in a chemical reactions and their practical applications in various fields. When bases react with acids, a chemical process called neutralization occurs. Neutralization is a reaction that results in the formation of water and salt. Bases and acids combine to neutralize each other's properties, bringing the pH closer to 7, which is considered neutral on the pH scale. Here is an overview how base reacts with acid. Base accepts protons. Bases have the ability to accept protons from the acid. This proton transfer occurs due to the presence of hydroxide ions in base. The hydroxide ions act as proton acceptors in the reaction. Acid donates proton. Acid releases proton when dissolved in water. These protons are the key component of acids that make them acidic. The acid donates these protons during the reaction. Formation of water. The proton from the acid combines with the hydroxide ion from the base to form water. This step helps neutralize the acidity of acid and the basicity of base. Formation of salt. The remaining ions from the base and acid combine to form a salt. Salt is an ionic compound composed of positive and negative ions. The specific salt formed depends on the types of cations and anions involved in the reaction. The overall reaction can be represented by a general equation: base plus acid reacting to produce salt and water. For example, when sodium hydroxide, a base, reacts with hydrochloric acid, this reaction occurs. In this reaction, sodium hydroxide accepts the proton from hydrochloric acid, forming water, while sodium from the base combines with chloride from the acid to produce sodium chloride, which is a salt. It's important to note that reaction between bases and acids is stoichiometric, meaning the amount of base required to neutralize a specific amount of acid is determined by their respective chemical equivalents. The balanced equation represents the mole-to-mole ratio of the reactants and products. The neutralization of acids by base is a fundamental concept in chemistry and has practical application in various fields, including medicine, industry, and environmental processes. When a base reacts with a metal, it can result in the formation of hydrogen gas and a compound known as metal salt. The reaction is commonly referred to a base-metal reaction or an acid-base reaction, as the base acts as a proton acceptor while the metal acts as a proton donor. Here is a general equation to illustrate the reaction. Base reacting with metal producing metal salt plus hydrogen gas. For example, let's consider the reaction between sodium hydroxide, a commonly used base, and aluminium, a metal. In this reaction, sodium hydroxide reacts with aluminium to form sodium aluminate and hydrogen gas. The base sodium hydroxide accepts proton from the metal aluminium, resulting in the formation of metal salt, sodium aluminate, and the release of hydrogen gas. It's important to note that not all metals react with bases in the same manner or to the same extent. Some metals, such as alkali metals, for example sodium and potassium, and alkali earth metals, for example calcium and magnesium, are more reactive and readily undergo base metal reactions. Other metals, particularly transition metals, may not react with base or may require a specific condition or additional reactants. There are several common examples of bases that are widely encountered in daily life and various applications. Here are some of them. Sodium hydroxide. Sodium hydroxide is a strong base and commonly used in manufacturing processes such as soap making, paper production, and the production of various chemicals. Potassium hydroxide. Similar to sodium hydroxide, potassium hydroxide is a strong base used in various industrial applications. Magnesium hydroxide. This base is often used in an antacid to neutralize excess stomach acid and alleviate symptoms of indigestion or heartburn. Ammonia. Ammonia is a common household base used in cleaning products. Calcium hydroxide. Calcium hydroxide is used in agriculture to adjust soil pH and in construction materials such as cement, mortar, and plaster. These are just a few examples of common bases. Bases can be categorized into different types based on their strength, solubility, and other properties. Understanding the properties and behavior of bases is fundamental in chemistry and has numerous practical applications across various fields. As we have discussed the formation, properties, reactions, and examples of base, that's enough for now. In the next episode, we will discuss about base in daily life. For more information about this or any episode of the series, check out the blog. Link is in the description. We have additional contents, further readings, and transcript of every show. We have also published our books on Amazon Kindle Publisher. We would love to see your reviews over there. Thank you for coming to the channel and watching the video. I hope you loved the show.